So when we look at quadratic relationships, a lot of area relationships tend to be quadratic, okay? Because when we talk about area, we're talking about squares or length times width, which is going to give us a quadratic relationship. So if we take a look at this problem here, we have an area of a rectangle is 30 meters squared, and one side is 7 meters longer than the other. Okay, so we're going to just draw a picture here. We're going to call this side x, and the other side is going to be 7 meters longer, so we'll call that 7 plus x. And so the relationship is that length times width is equal to the area of 30. In fact, when we can actually solve this relationship by making it equal to 0, and we can kind of guess and test at this as well, and you can just kind of figure out what factors multiply to 30. But here we have x plus 10, x minus 3 equals 0. So we know that the length x is equal to negative 10, which is not possible. So that's an extraneous solution, or equal to 3 meters. Okay, so the dimensions work out to be 3 by 10. Okay, so we have a 3 by 10 rectangle. Okay, so lots of area relationships tend to be quadratic. Okay, we're going to look at maximization and minimization problems where we're trying to find the maximum of a relationship or the minimum of a relationship, and essentially if they're quadratic, we can find the vertex of these relationships. So here we have rectangular yard. One side is bounded by 70 meter long barn. So here's our barn. And we have a total of 60 meters of fencing. Okay, well, if we have 60 meters of fencing, we want to use the side of the barn. Hey, although this is 70 meters, as long as it's not a restriction, we know that we can use the entire side of the barn. So it's not too short that it's going to wrap around, our fence is going to wrap around, something like that. Okay, so we're just going to have our fence here. And maybe I'll just do this in a different color. So we can have our fence here. We can say that the red length is going to be 60 meters of fencing. So how do I set this up? Well, it's a rectangle, so we can say that this is x and x. We'll call those two sides which are the same x. And then this length here is going to be 60 meters, but we got to take away that x and we got to take away that x. So we're going to start with 60 meters and take away 2 x's. And we want to find this area. And what we want to do is not just find the area, we want to find the largest possible yard. So we're trying to maximize this area. So what we want to do when we do any of these max min problems is, first of all, we have to identify what is the relationship. What is it that we're trying to maximize? We're trying to maximize area. So I need an equation for area, and this equation is going to be length times width. Okay, and so if I have length times width, I'm going to write it with the length and width that I've been given here. Length times width. Okay, and what I'm going to try to do is I'm going to try to maximize that. So if I want, notice that this is a quadratic function. I'm going to rewrite it. And so I get negative 2x squared plus 60x. Okay, so I can maximize this in a variety of different ways. First of all, I know it's a parabola opening down. I can find the maximum by finding the vertex. So I can use some symmetry here, or vietes. We can find the x-coordinate of the vertex and find the maximum area that way. We can complete the square. If we have a graphing tool, we can go ahead and use a graphing tool to do this. So this one I'm going to choose to complete the square. So the area as a function of x is going to be, okay, so I'm going to complete the square here. So I'm going to factor the negative 2 out. I end up with negative 30x plus blank. Okay, so I need to complete this square. So I'm going to take half the middle and square it. And then I have to make sure that I balance this equation. I have negative 2 groups of 225, so I have to balance it with a positive 450. So my maximum area is going to be 450, and the dimensions, well, we have to solve for x then. We have to find the x coordinate, which is going to end up being 15. Okay, so we know that the length is 15, so it's 15 by 60 minus 2 times 15 is going to be 30. So it's going to be a 60 by 30 area. And again, that's equal to 450 square meters. Okay, so this one doesn't actually ask for the area, but if it did ask for the area, from the vertex form we can find the area. For the largest pot, the dimensions, okay, we're being asked for the dimensions here, so really this is our solution here. Okay, it's 15 meters by 30 meters.